Okay, so when we talk about solving quadratics, we're talking about things that look like this. So ax squared plus bx plus c. Essentially what we're looking for is the highest power on one of the variables is squared. It's 2. So the steps to solving, the most important one is, number 1, get the equation equal to 0 first. I wrote it equal to 0 here, but sometimes it might be like c's over here, and you have to subtract it and move it there. This is the key. You need to get it to 0 first. If you don't do that, it's just not going to work out very easily. All right, so next, if possible, you should try to factor. So we'll look at ways to factor in a second, but then after you factor, you would set each factor equal to 0 and then solve for x. You'd end up with possibly 2 answers in this situation. Maybe one of them works, maybe one of them doesn't. And if factoring doesn't work, this is when you'd want to use the quadratic formula right here. And hopefully you all know the quadratic formula. You've heard it 1,000 times. Negative b plus or minus square root of b squared minus 4ac all over 2a. So when factoring, because a lot of these things that we're going to get in our class are going to be factorable, the first thing you want to do is check for a greatest common factor. So see if there's any number or term that's in all of the terms that divides out evenly. So let's look at this example right here. We have x squared, we have negative 2x, we have negative 24. In these situations, see how you can take a 2 out of both of these, but there's no 2 in here. So we can't use that for a greatest common factor. And these two both have x terms, but this one doesn't. So we can't take a greatest common factor there either. So in our case for this one, there is no greatest common factor, or it's 1, but 1 doesn't really help us. So we'll skip that step, but always check for it first because it might be super important. Then sometimes you might see a situation where you get a difference of perfect squares like this, where it's x squared minus 25. X squared is a perfect square, 25 is a perfect square, and the difference means that it's subtraction in between. With these, you can just take the square root of the first one and the second one, and then plug them in. You got x and 5. Those are the square roots of x squared and 25. And then you have x plus 5 for one of your terms times x minus 5 for the other one. And then, this is the one we're probably going to see most often, is as long as a equals 1. So essentially if a is 1 right here, what that really means is we're just not really writing it. It's just x squared plus bx plus c. That's a very common one of what you're going to see. So with this, you want to find 2 numbers that multiply to c and add up to b. So in our term over here, our c is negative 24 and our b is negative 2. So we want numbers that multiply to negative 24 and add to negative 2. And you could go through all the factors of negative 24 in your head, but I'll tell you right now that the numbers are negative 6 and positive 4. And then what you do with this is you're just going to do x minus 6 times x plus 4 equals 0. So now with this, we have 2 things being multiplied together. You have the x minus 6 times x plus 4 equals 0. The only way you're going to multiply 2 things and get it equal to 0 is if one of these, or both, equals 0. So let's try out when that would be the case. Here, if x minus 6 equals 0, that's true, and then x has to be 6. So that's one way that you could get a 0 here. Another way to get a 0 is you look at the other factor. And you say, what happens if the x plus 4 one is equal to 0? Well, you subtract 4, and then you get x equals negative 4. And these are your 2 answers to that equation right there. Now in geometry, a lot of the times we're going to want to plug them back in and make sure they make sense in terms of the context. Like for example, if this was like lengths or angle measure, negative 4 wouldn't make any sense because you can't have a length that's negative or an angle measure. Well, you can have an angle measure that's negative, but not in the geometric shapes we're going to see this year. So for this question, we want to find the side lengths of the rectangle if the area equals 20 units. So don't forget, it's a rectangle, so the area is just the base times the height. And in our case, it's going to be 20 square units. So you can name either one of these the base and the height. I'll call this the base. I'll call this the height. And what we want to do is we want to multiply them. So we're going to end up with x plus 12 times x plus 4. And this should all equal 20. So what you want to do now is distribute here. So we'll get x times x is x squared. X times 4 is plus 4x. 12 times x is plus 12x. And 12 times 4 is 48, all equal to 20. So we can combine like terms really quickly here, and then we get x squared plus 16x plus 48 equals 20. And then what we should do here, of course, is get it equal to 0. So to get it equal to 0, we got to get rid of this pesky 20 on the right side. So the way to do that is subtract 20 from both sides. And then that cancels out. And you're left with x squared plus 16x plus 28 equals 0. So now let's try to factor this thing. First off, there is no greatest common factor. So we're looking to see if we can break it into this. And what we want to do is we want numbers that multiply to 28 and add up to 16. These aren't too terrible. It's actually just going to be x plus 2 and x plus 14. Cool. So in order to do this now, we're going to set each factor equal to 0. So we're going to do x plus 2 equals 0 and x plus 14 equals 0. We subtract 2 on the left here, and we get x equals negative 2. Or we subtract 14 over here, and we get x equals negative 14. So these are our two possible answers. Now, remember what I just said about not having negatives for lengths? These are both negative, which feels like a real problem. However, we got to plug them into this first. So let's try the negative 14. Let's try plugging that in. I'll do it in blue. So let's see, we have negative 14 plus 4 if we look at this side right here. Well, that equals negative 10. Now that's the side length, negative 10. That doesn't work. So what that means is x equals negative 14 does not work as a solution. All right, let's switch over to red for this one. We'll try out x equals negative 2. So with this, we're going to negative 2 plus 4. That equals 2. Okay, that's good. And then we'll try it here. We get negative 2 plus 12. That equals 10. Good, that's positive, so that's good. And then just a real quick check, is 10 times 2 20? You bet it is. So our answer for this problem, x equals negative 2 is what we use, and it's looking for the side lengths. So the side lengths are 2 units and 10 units.